So as promised, here is the sign chart YouTube video to get you understanding, I guess, two different ways to do a sign chart. So I'm going to start off with making sure you understand what a sign chart does. So if we call the function here f of x, and if we want to create a sign chart for f of x, it's really asking when is the function going to be positive, when is the function going to be negative, and when is the function going to be 0. So if we remember from class, sign charts must have x-intercepts, so where the function is equal to 0, and then also where the function is undefined. Okay. In this case, since this is a polynomial cubic function, the domain is all real numbers and there are no undefined points. Therefore, the only values that I'm putting on my sign chart would be zeros. Those correlate to these 2 points here. Then from that point forward, I would do the sign of the graph by looking at, is this portion of the graph positive or negative, and that is below the x-axis, so it's negative. If I look at the next portion of graph, that's this piece right here, is that portion of the graph above the x-axis or below, and since it's above, we consider that positive. And then the last piece here, since it's above the x-axis, that would also be positive. So that would be the sign chart for this function f of x. The problem that I told you I would do for you was this problem that you had from the intro worksheet for 3.4. I asked you to try to make a sign chart based on this function, and what I'll do first is make sure you understand that you were asked to make a sign chart for f prime, and I gave you f prime. The first thing I'm going to do is make sure we have it factored. And then below, probably also factors. So the factors are given, and what we're going to do is set f prime of x equal to 0. But what I'm going to first do is rewrite the factors. And set it equal to 0. And then I am also going to set the factors equal to also equal to undefined. So I'll just put a U for undefined because I'm running out of space. And this one will be for where f prime of x is equal to 0. So given that I want f prime of x equal to 0, I would actually multiply both sides by the denominator, but anything multiplied by 0 would cancel. So I actually am left with 2x minus 3 and 3x plus 6, which equals 0. Therefore, my two zeros would be positive 3 halves and then also negative 2. When I want to set this equal to undefined, we have undefined values when the denominator is equal to 0. Therefore, the values I get from these factors would be x equal to 5/4 and x equal to negative 4. So there are my 4 points that would go on my sign chart. So here we have our x values that make the derivative equal to 0, the x values that make the derivative undefined. So I'm going to do a sign chart now. Start with making, let's move that down a little bit. I'm going to need a little bit more space for this guy. And then also, I want to make sure that it is a black color. So that's a little bit easier for you to see. Okay, so here we go. We have the 4 values, and what I'm going to do over here is label my sign chart. F prime of x. I'm going to place all my values in numerical order, and I'm going to leave enough space between them so that I can write. Next one would be negative 2. Next one would be 5/4. the next one will be 3 halves. So here are my values, and we know that when x is 3 halves, it's 0. When x is -2, it's 0. When x is 5/4, it's undefined, and where x is -4, it's undefined. So here's the other way to handle this type of problem. Now the reason I'm using this, you'll notice that in between 5/4 and 3 halves, you might have some trouble finding a good number to use between them. So that's why I'm trying to show you another method. So here is the way that we can actually handle this. So I brought back the factors, and what we're going to do is actually write down each of the factors and do a sign chart per factor. I'll show you why this is so much easier. So down here, I'm going to start with, in purple, blue, 2x minus 3. So if I pick 2x minus 3, the 0 for 2x minus 3 was positive 3 halves. So if I were to only look at positive 3 halves, and I use any value less than positive 3 halves, then I know that if I use, say, negative 100, that the value to the left would be negative all along here. But after 3 halves, I get that they're positive. And the only reason I'm putting a bunch of them is so that you can easily see the signs when we're done. The next factor would be 3x minus 6. So 3x minus 6, the factor for that guy was, or plus 6, that's why, was -2. So go to the left of -2 and pick a value that would be a value less than -2, -1000. So that would give me negatives. But then once I hit -2, it'd be 0, and afterwards it'd be positive. So then the factor after that would be in orange, 4x minus 5. 4x minus 5, that was this factor right here, 5/4. So to the left of 5/4 would be something like 0. That would cause this to be negative. First, till I get to 5/4, and then positive after. Because if I pick 1,000, the value will be positive. And no, you don't need to write this many of the positives and negatives. And then the last one, which I'll do in light pink. Actually, I guess I should use red here. All right, the last one is x plus 4. That's the factor of -4. So it would be negative until I hit -4 as my value. That's this guy right here. And then it would be positive after. Let's space these out a little bit more. So why can this be helpful? Because now when I look at it, I can look at the signs going straight in order. The signs through here would be negative, 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 would make this sign positive. Then I would go through this section right here, positive, negative, negative, negative would make it negative. I would go through this section right here. We have 2 negatives and 2 positives, which would make it positive. I would go through the next section right here, which would be 3 positives, 1 negative, making it negative. And then in the end, I would go through this section, which are all positive, giving me a sign of positive. It definitely takes some more time because you're doing each factor. But if you're having a really hard time doing your sign chart just because you're doing each factor in your head, this is a method that will guarantee that you get your sign chart correct. And once in a while, I'll try to use the method in class in case you're not familiar with it and you want to get some practice. Otherwise, you would probably see my answer look more like the top part of the sign chart. You won't see every single factor shown, but this is a way that you don't have to worry about trying to find a number between 5/4 and 3 halves, because that's 1.25 and 1.5. So having to use, say, 1.3 or 1.4 can be difficult for some of you. And in that case, this method can work instead. So that's all I wanted to show you for sign charts. Enjoy.